Hello friend, welcome back. Okay, in this video we'll play Collatz Conjecture in Python. Okay, what is Collatz Conjecture? Is Collatz Conjecture is about a sequence of counting numbers. Okay, so the rule is if the current one is, for example, 3, the next one, if it's an odd number, then the next one will be, so let's say n. So if n is odd, the next one will be, the next n is, right, if is 3n plus 1 if it's odd. Otherwise, if odd, and half n otherwise. Okay, so it means, yeah, let's put an example here. So for example, the first one is 3, so it's odd, right? So next one will be 3 times 3 plus 1, so it's 10. Now this guy is even number, right? So next one will be half of that, so it's 5. So next one, because now the current one is odd number, right? So the next one will be 3 times that plus 1. So 3 times 5 is 15, plus 1 is 16. Okay, now it's even number, so half of it next, right? Even number again, half of it. Okay, 2 and 1. If we keep going, so 1 is odd number, so next one will be 3 times that, and it will be 4, right? 3 times that plus 1. So you see, you will loop. So it means the Collatz conjecture says whatever it starts with, it will always end with 1. That's cool. This is one of the famous open mathematical conjecture problems, right? Conjectures. So no proof for now. No one knows it's true or not, right? But whatever we try, it's always true. So to play with that, we need to introduce while loop. So while loop, let's write some code to for while loop. Okay, so let's define a counter like 5. So while counter is is greater than 0, so we'll do print out. Can we do that? Print out the count. Then we'll decrease it, right? Otherwise it will be a infinite loop. So you see, it means it originally is 5. So we'll print out the 5, then it will become 4, right? 5 minus 1. So go to the next. 4 is greater than 0. So we'll print out 4. Now 4 minus 1 is assigned to count, so it will it becomes a 3. So 3 out. 3 is still greater than 0. Okay, let's try it, evaluate. Okay, cool, right? We don't have 0 because 0 is not greater than 0, so it will skip. It will end the for loop. Okay, and now let's try to play with so here is how we print out, right? Output the 5, 4, 3, 2, 1. So what if we change this to 0, and we have to change this condition, right? Like less than 5. So we print out 0. Now we increase it, and I think that there's okay, so the shortcut for evaluate button is shift enter. Yeah, 0 1 2 3 4, and this one has a shortcut syntax plus equal. That's right, shift enter. Yeah, now let's use this to play with Collatz. Okay, so let's say the number start from 3 while n, right, is not 1. We'll do, what do we do if the n is even, right? How can we check even? Modulo, right, divided by 2, the remainder of the division. If that is 0, it means it's even. So we'll do this equals n half of that, right? Otherwise, oh, like that, right? Otherwise, n equals 3 times n plus 1. That's it. So this one is the while inside the while loop, okay? This block, and this part is the when the if condition is true, and this part is inside the block of else. So in other programming language, we use something like that. Yeah, in other programming, in many other programs, we use something like that, but here it's different. We don't use the curly braces in Python this way. Okay, undo. Okay, now shift enter. Oh, we don't have a print. Okay, that's why we can see nothing. And while if that, so let's print out n here, right? So shift enter. It goes back to 1, you see? So 10, let's print out the first one here, right? Otherwise we cannot see the n itself. Try it again, shift enter. 3, so next one is 10, and 10 is even, so the next one is 5, and the 5 is odd, right? So 3 times 5 plus 1 is 16. Yeah, it's exactly same as what we tried manually, right? Now let's try a different number. What about 7? So shift enter. Oh, this is a longer list. Yeah, it returns to 1. It does return to 1. If it doesn't, then we'll be famous, right? We'll be famous. That's a top news in the whole world, okay? In the mathematical world. Can we try some like bigger number? I like prime numbers. This is prime number, okay? Yeah, it returns to 1. What about non-prime number? Evaluate. Wow, it's even longer, but it always returns to 1. That's amazing. That's amazing. Let's use a longer prime number. This is a prime number 2. Okay, Shift enter. Okay, yeah, it's guaranteed. No, no proof. It's still an open mathematical problem. Okay, so that's it. Thank you for watching. See you next time.